Hello dear students, welcome to Akshat International School online classes. In our previous video, we had discussed about the area under the velocity time graph represents displacement. That means we had studied about the areas under the graph. Okay, means if the graph is given, with the help of the graph, we can find out the different physical quantities. Okay, and out of that, we had studied that if we have a velocity time graph, in that velocity time graph we can find out the displacement of an object, okay, or a body just by using the graph. Fine. Today we are going to study the last topic of this graph, that is slope or gradient. Fine. Now what is the slope represents in the graph, or what is slope or gradient, that we have to study in this graph. Okay, and after that it will be very easy to understand the equations of motion, or how to derive the equations of motion with the help of graph. Okay, so let's start today's class. Okay, now as I said, slope or the gradient in a graph. Fine. Now as we had seen the two types of graphs, now out of that, first I am using the distance time graph. Say on y-axis, suppose if distance is represented, means on y-axis I had represented distance, and on x-axis, as you all know, okay, this is also known as time axis, so I had represented time on x-axis. Fine. Now as, or suppose the object is moving uniformly, then we know very well that we'll get a straight line inclined to the time axis. Now as I was using this word inclination or inclined, that itself represents the slope. Okay, like this one, this is called the slope, this is called the slope of distance time graph. Fine. This slope represents in a distance time graph, be careful, in a distance time graph, this slope represents the speed of the object. Okay, that how fast the object is moving. If we compare the speeds of two objects, and if we do not have any data, but simply if we have the distance time graph of both the objects or say vehicles, with the help of the slope, with the help of that inclination, we can find out the speed of the graph, or just we can say that which object is moving faster. Okay, let's take an example. Like suppose this is the graph for car A. A car is moving, okay, and this car is moving uniformly, and this graph represents the speed, position, distance and time. Fine. Now suppose I have another car, say this is car B. Okay, now which car is moving faster? If we have to find out, then we'll just see the slope. Okay, that means we'll find out that the graph of which car has the greater inclination. Fine, with the time axis. So car A is having more inclination as compared to car B. Okay, so we can say that car A has more speed. Okay, let me elaborate more. Fine, like suppose I'll draw this graph for a vehicle. Say again we have a car, say this is position, this is time, this is your y-axis, this is your x-axis. Okay, now suppose this is the graph, means car is moving uniformly. Now you can see that different points are representing, like this point, that means at time t or say any time, say after 5 seconds, car covered almost say 10 meters. Okay, here in 5 seconds, car has covered 10 meters. Fine, then what will be the speed of the car? Because this graph is uniform, okay, that means at every point, the speed should be same. Okay, that means suppose this is say 2 seconds, this is say 2 seconds, then this will be say this 10 by 5 will be 2, fine, so this will be say 4 meters. Okay, so the speed of the car say 10 upon 5, isn't it? The distance covered divided by the time will give the speed, fine, so this will be 2 meter per second. Similarly, if at this position, if I have to find out the speed, say 4 by 2, again it will be 2 meter per second, because this is uniform. Fine, I'm not explaining that this graph is representing uniform motion, but instead we are discussing that how we can compare the speeds. That means this slope actually represents the speed. Okay, it is basically distance. This will be representing, this part will be representing distance, and this will be representing time. Fine. So if we take the ratio of these two, that is, this is perpendicular and this is base, if we take the ratio of these two, we'll get the slope. Fine. So we can say that at slope in distance time graph, say xt graph, represents the speed. Okay, I can simply write that slope will be equal to here distance upon time. Okay, now if I draw the same graph which I had drawn earlier, and we can compare that which car is moving with greater speed at same time. Okay, say let's draw the graph again. The graph which I had drawn earlier, that is in which I was comparing the speed of two cars. Okay, say this is the graph for car A and this is the graph for car B. This is for car B. Okay, now this is the slope of car B and this is the slope of car A. Now you can see in this time interval, say let me draw this one. So here, say at 5 seconds, okay, here also if I take say same time, if I take, then the distance covered here, the distance covered in 5 seconds is less than the distance covered by car A in the given 5 seconds. Fine. That means we can say that in given interval of time, car A had covered more distance and car B had covered less distance. Now this is only possible when car A is having more speed than car B, because in given interval of time, if a vehicle is covering more distance, then we can say that the speed of that vehicle will be more than the speed of the car B. Okay, so simply by seeing the slope, we can find out the speed of the vehicles in a distance time graph. In a distance time graph, we have to be very careful, because in exams it is asked that slope of distance time graph represents dash. They'll give fill in the blank, that we have to fill the blank. Okay, slope of distance time graph or say displacement time graph represents dash. So distance time graph, the slope of distance time graph will represent speed, or if we have a displacement time graph, it will represent velocity. Okay, now as we are studying only straight line motion, and in straight line motion in one direction, the speed and velocity will be same if you are not changing the direction. Okay, so in distance time graph, slope represents speed or velocity. Fine. Now, suppose if I have a velocity time graph. Okay. Now, in a velocity time graph, again, we'll take the same like velocity time graph. Suppose if I have this straight line inclined to time axis. Now we all know this represents uniform acceleration, isn't it? Okay, so this again, if I draw a perpendicular on x-axis, then I will take the ratio of, to find out this slope, I will take the ratio again, this one, that is perpendicular and base. So here the slope of velocity time graph represents, what is this? This is v, this is velocity, and this is t, so it will be v by t. Fine. Now we know that v by t is acceleration, that is velocity upon time, change in velocity upon time. It will represent acceleration. So that means in a velocity time graph, slope represents acceleration. This is again very important, and this we are going to use in the derivation of the equations of motion. Fine. That this slope represents the acceleration. That means in a velocity time graph, the slope represents acceleration. Okay. Actually, why I am taking this ratio? Well, in class 10th you are going to study a branch of mathematics, that is trigonometry. Okay, in trigonometry, this slope, this ratio have a proper explanation. This is called tangent of the angle or tan of angle, that we'll see in class 10th. Okay, this represents this perpendicular and base. This ratio represents this and the tangent of this angle, which is basically the slope. Okay, that you don't have to worry about. Fine, we'll see that in class 10th. But here the point that you have to be noted, and that point is that the slope of velocity time graph represents acceleration. Okay, slope of distance time graph represents speed. Fine, these two sentences you have to remain okay in your mind. It should be remain in your mind. Fine, because these type of questions are asked in the exam. Fill in the blanks or MCQ. Okay, these questions are asked. So we had studied two different things. First, that the slope of distance time graph represents speed or velocity, and the slope of velocity time graph represents acceleration. Okay, so these two things you just keep in your mind. Fine. Now let's discuss something which is little bit important and difficult to understand, because like uniform motion, whatever uniform motion graph I had drawn, in all the graphs I had taken the object which is starting from from origin, from zero. Okay, you will say that, sir, what if I get a graph like this? Now what is the difference between these two graphs? That if I have a graph like this which is starting from origin, okay, and the graph which is starting from at say this point. Okay, let's see, this is the velocity time, so this is the distance time graph, for example. This is also say the distance time graph. This is very important. Okay, now what is the difference between these two graphs? These two graphs are representing different types of motions? No, both are representing the uniform motion, but the only difference is that one of the object had started from this point, say this is the origin, okay, and this is at the different point of origin. Fine. This car or this vehicle or this object had started from different position. Okay, so the difference is only the positions, that this started from different position because this y-axis is representing the position, so this position is different from this position, but the slope will get here. I mean, this will represent whether you take the point this one. Okay, here you are going to drop it. This will be same. That means the object is moving with uniform motion because this all angles, this is the slope, this is also the slope, and they are equal. That means the object is moving uniformly. Okay, so this also represents the uniform motion. Fine. Similarly here also, if I take this slope, or I take this point and I take this slope, this point and this slope, all are equal. If they all are equal, then we can say that object is moving uniformly. So if suppose in a graph you see that it starts from some other point other than this one, and don't get confused that these graphs actually represent the different positions. Okay, like suppose if we have in a track, like in a racing track, we have different positions in a relay race. You have seen. Okay, the athletes have different positions, but at the same time they start at the same time, but with the different positions. Fine, and if they are moving uniformly, then we will draw the graph in this way. I have to draw the graph of two athletes who are just racing for that what's a relay race. Fine. In that case, one athlete is starting point is different and the other athlete starting point will be different. But at the same time, that means they both had started when the time is same. Okay, so these graphs didn't represent any other different things, but they have the same meaning, uniform. They are moving, the objects are moving in uniform motion. Similarly, suppose if this represents, this is a velocity time graph. For an example, this is a velocity time graph. In this also, in this velocity time graph, when we had started the observation, the velocity of the object is something different. This will be the initial velocity, and here the initial velocity is not 0 because we had started the observation of the object from this point. But in this case, the initial velocity will be 0. Okay, so if we have to observe two different points, at this point if I have to observe, then now this will be the initial velocity and this will be the final velocity. Okay, so at this time will be 0. So when the object has started, the velocity of the object is u, and after some time we observe the velocity. Say after this time we had observed the velocity is this one. Okay, these velocities are different, but the object is moving uniformly. Okay, so don't get confused that, sir, these graphs represent something different, but they are representing the motions, different motions, but both are uniform motion. Okay, like again, let me draw clearly. Okay, say this graph and say this graph. They both represents uniform motion. If it is a distance time graph, okay, the starting point of two objects is different. Okay, and if it is a velocity time graph, in that case, the velocities, the initial velocities, in this case, the initial velocity will be 0. In this case, the initial velocity will be something. Are you getting me? So, the slope of an object, the slope of a graph, a velocity time graph, represents what? Acceleration, and the slope of distance time graph represents speed. Okay, in the next lecture, we are going to study about the equations of motion and the derivation of equations of motion and the numericals. Okay, so that's all for today's class. Thank you.